All right, geometry, let's talk 914. So if you look at our Google Doc for homework, you will see that this very image is right there on a note sheet. You can print that off or you can copy this table. But what I'm going to do is, from the comfort of my desk, I'm going to fill it out, type it, all that kind of thing. And I am going to work out with you these values and also this first question, part A. We're going to work that out. So I'm going to be working from this doc, and so you'll see me typing in this. Again, if you have your notebook, you can just take this in your notes. It's no big whoop. You don't have to print this, but you'll see me typing in here the solutions, the answers. So here's the deal. They gave us this net, and we should recognize this net, because this is the net that I drew on the board. It's just flipped over. It's this flipped over version of the net I drew on the board of the box that was in the last section. This is why we did 913 and 914 together in one day. I would say that this thing is a box unfolded with dimensions 2 by 3 by 4. It has a height of 2, a width of 3, and a length of 4. And that's about all I really need to say there. It's just, it cannot be sexier than that. That is it. All right, now getting to this deal here. What is this deal? Yeah. Now, if we were in teams, I would have you with a piece of graphing paper, and one of you would take the 1, and one of you would take the 2, and one of you would take the 3, and then one of you would take the 4, and you would find the volume of this, and then someone else would double the dimensions. Every dimension would be doubled. Like when I say dimension, I mean length, width, or height. So the length is doubled, the width is doubled, the height is doubled. So instead of being 2 by 3 by 4, it's going to be 4 by 6 by 8, and it gets bigger. And then another teammate would triple the dimensions, 6 by 9 by 12. And then the last teammate would need multiple sheets of graph paper, and theirs would be 8 by 12 by 16. And all of these shapes get, each of these bits gets that much bigger. And all of this is a study on, well, what happens? What happens to the volume? What happens to the volume when I double the dimensions, when I triple it, when I quadruple it? And we're going to talk about, I hope you remember how we did the ratio when we were talking about polygons. So if I say I took a triangle and I doubled its dimensions, what did that do to the perimeter? What did that do to the area? And I hope that you remember that the perimeter had the same ratio of small to big triangle that the original sides had. So if the little triangle had a length of a side that was half the length of the big triangle, then the perimeter was half the perimeter of the big triangle. But we found out, I hope you remember this, that if the ratio of the sides was 1 over 2, the ratio of the areas was 1 over 4. Then we did rectangles, and we found out that if the ratio of the sides of a rectangle, a little one to the big rectangle, it was 2 to 3, then the ratio of perimeters was 2 to 3, and then the ratio of areas was 4 over 9. 2 squared, 4, over 3 squared, 9. So we went from the ratio of the sides to the ratio of areas. Now we're asking the question, well, what if I do the ratio of the sides and I compare their volumes? That's what we're talking about. Volume! So I'm going to work these out. Again, I'm going to just type them right in the box, and then I'll upload this completed thing. And hopefully you'll watch the video with it in case you just see the completed version. You should really watch the video. It's 2 by 3 by 4. That's the original one. 2 times 3 is 6. 6 times 4 is 24 square units. So the new volume. Well, all the dimensions are the same. I'm multiplying 2 by 1 and 3 by 1 and 4 by 1. So since all the dimensions are the same, I can drop that in here. It's the same volume. And the ratio of volumes is going to be, well, 24 divided by 24, that is 1 to 1. That's a way of writing ratios. You're probably going to want to see an equation because you're so picky, you and your pickiness. So I'm going to insert an equation. I don't know if you know this is part of Google Docs. It's kind of a sweet feature. You can put in an equation and done and done. Yeah, it's kind of sweet. Now I wonder if I scooch this up, will I still get, yes I will. Okay, so now this original volume is going to be the same all the way down this column. So I'm just going to paste it in here. And then here. And no matter what I do, no matter what number goes in here, it doesn't matter if I make it 12,000 times bigger or just 4 times bigger, the original volume is the original volume. So I'm just going to fill that in here and we're done. Okay, so all the way down that first column, the original volume is the original volume. All right, now, what if I double all the dimensions? Well, if I double all the dimensions, instead of 2 and 3 and 4, if I double all those, I will have 4 by 6 by 8. 4 times 6 is 24, and 24 times 8 is 192. This volume got big in a hurry. So I want to go back here and I want to make another equation just for kicks and grins, squirts and chuckles. And I'm going to pop this in here. My original was 24, and I got to get the cursor back in there. And then 192. So that equals, so I'm going to add a new fraction to this. Again, it's a sweet little feature. And if I get out ye old calculator and I type in 24 divided by 92 on ye old calculator, I get that. And that means nothing to me. And I hope you remember this trick, math, enter, enter, and it turns it into a fraction. Hey-oh, 6 over 23. Well, that's kind of kooky. Yep, 6 over 23. I don't know why it's 6 over 23. I feel like I typed something in wrong. Yep, that's what I did wrong. It's supposed to be 24 over 192. Bam! Again, that doesn't make any, doesn't mean anything to me. So I'm going to change it to a fraction. That's 1/8. That's interesting. 1/8. I'm going to come back to my little equation later on, but that's an interesting ratio, 1 over 8. Okay, so now I go here. I'm going to triple all of these times 3. So 2 times 3 is 6. 3 times 3 is 9, and 4 times 3 is 12. So 6 times 9 times 12, and 12, bam, 648. Hey-oh, that's a big old number, Yahtzee! Square units, we're talking about volume, Aiken. Oh boy, do I feel dumb. These should all be 3s. My apologies. You're probably sitting there at home shouting at your Chromebook. Old man, it's cute. We're talking volume. What's your problem? What? I want my tax dollars back. So, my apologies, and thank you for accepting my apologies. But yeah, it was supposed to be cubic units. And now I'm going to do the ratio, just like before. I'm going to create an equation. And my fraction is 24 over 648. And I'm going to create another fraction. And on my calculator, and I hope you can trust me, 24 divided by 648 is some crazy decimal. But I go math, enter, enter, and it turns it into a fraction, which is 1 over 27. Which I think is an interesting number. And you'll see why in a little bit. Let me do another one. 4 times each of these. So it is 4 times 2, 8. 4 times 3, 12. And 4 times 4, 16. It's going to be a big old number. 8 times 12 times 16 is 1536 cubic units. That's big. So I am going to create another equation. And so I'm just going to put that 24 over the 1536. And that is the same as if I made a fraction. Let's see here. I'm going to do that on my calculator. 24 divided by that 1536 gives me a weird decimal. Math, enter, enter, gives me 1 over 64. That, my friends, is downright interesting. Well, gosh, I don't know what to do now. But what I'm going to do is this. I'm going to put this R, I'll slide it up a little bit for you. This is a ratio. They use the letter R for ratio, or maybe a better letter would be M for multiplier, because like we multiply all these numbers by 4, so maybe M would be better, but they use the word ratio because we're creating ratios, and that's okay. But what we did in the last row is we did 2 times 4, and 3 times 4, and 4 times 4. We just multiplied each of those numbers by the thing out here. So that means I have 2 times R, and then that is going to be 3 times R, and then that is going to be 4R. And what is that? Well, 2 times 3 times 4, we know that is 24. I can get that from over here. But R times R times R, well, of course, that equals YAR! No, that's not what that is. That is a big mistake. I don't know what I just did. I'll go back. My apologies. I meant to hit a different key. R to the third. We know that it's R times R times R, so it's 24R to the third. Now I want to just tap the brakes for a hot second. For just a moment, I want to tap the brakes. And we'll fill this in a minute, but I just want to see here. Down here, it says R to the third. I find that interesting. The number 8 should ring a bell, how it connects to the number 2. The number 27 should connect with the number 3 in your head. The number 64 might not connect in your head, but I hope it does. What I'm going to do is I want to fill this in. I want to show you something. What we just found out, if I follow the pattern of everything else that we've done, what we just found out is that we put the original, 24, and then we kept doing that. We just did 24, and then we did the number to the right, just to see what the ratio is. What kind of numbers do we get? What's happening? So I'm going to put the 24 oops, I gotta do that up here, my bad. To do a power, I've gotta do it this way, r to the third. That's an interesting reality. That's kind of quirky, you know, kind of different. And if you look at this really close, and I will zoom in a little bit more. Hopefully you can see this pretty well. If you look at this really close, I have a 24 on top and I have a 24 on the bottom. I can cancel those out. They reduce. So what I'm going to do is rewrite this without those 24s. That means it is 1 over r to the third. Here's what I want to point out to you. And I want you to really kind of like drill this into your cabeza, okay? So you should be leery when anyone says to you, oh, well, that's twice as big. Whoa. Twice the area? Twice the volume? Or just twice the length and width? You should be leery. You should tap the brakes. You should be like, hold on, time out. What do you mean by twice as much? Because here's what happened. When I took the original box and I doubled its dimensions, I made it twice as wide, twice as long, and twice as tall, I didn't have twice the volume. I had 8 times the volume. That's what this is telling me. When I tripled the sides, I had 27 because 3 times 3 times 3 is 27. I had triple the volume. I'm sorry, I had 27 times the volume. I didn't have triple the volume. I had 27 times the volume. And last but not least, if I made the box 4 times as wide, 4 times as deep, and 4 times as tall, I didn't get 4 times the volume. I got 64 times the volume. So if you have a box in which you're going to put a cat and you're going to ship it, UPS, and you're like, you know what? I have a lot of cats and I need to get rid of them. So I'm going to make it 4 times as wide, the box, 4 times as deep, and 4 times as tall. That means that box can hold 64 cats. So you went from a box that held 1 to a box that held 64. And by the way, that'd be a big, loud, scratchy box. But it's worth it to get rid of cats. And good for you for trying. So let's say I just did something crazy. And I took that same box and I said, you know what? I got a lot of cats. And I want to get rid of them. So instead of 2 by 3 by 4, and I shove a cat in there, what I'm going to do is I'm going to make it big, big, big. I'm going to make it 10 times. So instead of 2 by 3 by 4, I'm going to go 20 by 30 by 40. Now, I don't need to figure out that new volume. I don't need to do a ratio. All I need to do is go 10 to the third power. That means I can get rid of 1,000 cats. That means I have 1,000 times the volume of the original box. Okay? Volume, the units are cubed on volume. Cubic feet, centimeters cubed, that kind of thing. So when you make a figure bigger by some dimension, some multiplier, or some ratio, you have to take that number and take it to the third power to find out what the new volume would be. That's what this is telling you.